up. Okay, let's start with a little bit of informal review on some of the things you guys should have learned over the last couple of days. I just want to make sure that you all feel comfortable with the skills we have up till now. So, the first day we talked about factoring. Okay, and hopefully that was a review for most of you guys. The main things I need you to have the ability to do are these four types of factoring. Right? Are you able to look at a factoring problem and recognize whether it's common, simple, complex, or different? And do you possess the ability to solve or to factor those ones? Okay, and that was actually like grade 10. Like we did this in grade 10. So hopefully that was more or less review. The next day, I taught you guys along with the 30-1s. We did that work on synthetic division. I'm not going to assess you on this whatsoever. So, I mean, if you really want to just ignore it and be like, wow. But I thought it was valuable because most of you guys are going to do 30-1 next year, I'm thinking, right? And so I thought it was worth just showing it to you now in context of how to long divide. So the next year, you're like, oh, yeah, we saw that a little bit. Okay. But really, I just thought that made sense to do 20-1 and 30-1 together just for one day. But please don't freak out that I'm assessing you on this little bit here because it's not actually really your full curriculum. So, the next day, you guys would have worked on the quadratic formula, and this would have been new. So I just want to make sure that you get the concept here. If I were to give you this one right here, 3x plus 5 minus 2, and I ask you to factor it, you're looking for like the special numbers, right? Add to give 5, multiply to give minus 6. And if those numbers exist, you should be able to factor. But what happens if I make just a slight tweak? I hope Mr. Bonnet pointed this out well here, but see how the only difference between these two here is one's a minus 2, one's a minus 3? Well, now try it. Now we need to look for numbers that still equal 5, right? Because nothing else changed. The 5 didn't change. But now we're looking for numbers that multiply to give minus 9. There's not a lot of stuff that multiplies to give minus 9, right? 1 and 9, 3 and 3. None of those equal 5. So the whole point behind the quadratic formula is that if you want to solve something that you cannot find these numbers for, it does not appear that they work, it actually can still be solved. Okay, there's a way. And I found that at first you just have to take my word for it. Later on in the year, I or somebody will show you where this formula came from. Okay, we're actually going to prove it. But for right now, is it fair enough just to say that, like, I just need you to know how to use it? Is that a good enough starting level? But if you're like, who came up with this? Where did this magic come from? Like, we'll get there. We just have to work our way there. So this is a formula that will literally solve any equation, even the easy ones. Okay, like even for something that you'd be able to do, like say x squared. Goodness, I'm not writing it properly. Let's try that again. X squared plus 3x plus 2 equals 0. Okay. Could you factor that? What are the numbers that add to 3 times to 2? 1 and 2, right? Okay, so factoring was easy, hopefully. And then the last step of solving just means that this means that x is minus 1. This means that x is minus 2. Even that one right there, let me show you. You can use the quadratic formula on it. The formula is negative b. What would b be in this formula? 3, yeah. Plus or minus b squared minus 4a 1. I know the 1's not written, but it's implied, right? C all over 2a. I'm going to do most of this in my head. 3 squared is 9. 4 times 1 times 2 is 8. 9 minus 1. Sorry, 9 minus 8 is 1. I'm ahead of myself. So this is really minus 3 plus or minus the root of 1 over 2. Does 1 square root? Yeah, square root's to 1. So really, let's just ignore the square root. What is minus 3 plus 1? Minus 2 divided by 2? Well, that's minus 1. What about minus 3 minus 1? Negative 4, divide that by 2? Yeah. So just so you guys are aware, because someone asked me this question already, I want to make sure it's clear. The quadratic formula always works. If you would like to always use the quadratic formula to solve, you could. But I think that's poor teaching skills because sometimes it's not the most efficient way. Right? And my goals in math are not just to teach you math, but to teach you problem-solving abilities and thinking skills. And so sometimes you need to figure out like the most logical way. Like if every problem was just, sometimes I think we fail you guys in math by saying, I want you to find a way to solve a problem. Like, let's say that I asked you the problem, I want you to get from Fort Macleod to Lethbridge. And you drove all the way up to Edmonton, all the way over through Saskatchewan, back down and back through Lethbridge. You did solve my problem. You made it from Fort Macleod to Lethbridge. But that's ridiculous, right? I think that same analogy applies to math, is that although there's lots of ways of solving, part of the skill is knowing, like, what's the smartest way, right? So I want to encourage you, use the quadratic formula when you're stuck. Like when it does not seem like you can solve it by factoring, use the quadratic. But don't just use it all the time. Fair enough? So, okay, let me fast forward here because I've got 35 minutes now to do our set of notes. There's one thing that you guys have to do that's extra on top of the 20-2s and 30-2s. It's called a system of equations. And once you get the concept behind this, it's one step further than where we've been. Okay. You guys actually should have learned a little bit about this because I know I taught you guys this in 10C if you were in my half. Because I went a little bit more than I should have last year, just knowing that this was coming up. So, if I were to give you these words here, single variable and multivariable, we often work with single variable math, where literally the only thing in our equation we don't know is an x. Okay? And so, do you guys think you have the skills to be able to solve for what x is right here? Let's not solve it, let's talk through what you would do. How would you solve it? Okay, so FOIL the crap out of both sides. You would get like an x squared plus blah equals a 2x squared plus blah. And what would you do? Okay, so shove all this stuff on one side, make it equal to 0. You'd have x squared plus blah. Then how do you solve a quadratic? If you can factor it, factor it. But now, if you can't factor it, use the... Okay. And when you're done, you get answers for x. That makes sense. So that's single variable math. And you guys have all done single variable math at some point in your life. However, there's also multivariable equations. And those usually involve multiple letters, hence multivariable, right? Here's a good example of one. Y equals 3x plus 4. We would have done like graphing equations at some point last year. You know, like y equals mx plus b. You guys recall that at all? Well, this is different because now there's not just an x that's unknown. There's also a y that's unknown. Okay? And so multivariable equations usually use x and y, and in theory you could even go to z and w, and you can use more letters as you want. But most of the time it's just x and y. The downside to solving these is that this one right here, you really can't solve for what x and y are, because it really they kind of depend on each other. Depending on what x is tells you what y is, or depending on what y is tells you what x is. I really can't isolate. You get what I'm saying here? But as a general rule of thumb, I'll put this on this slide here. There we go. You need one equation for each variable. If I give you one equation and one variable, you can solve. If I give you two equations and two variables, you can solve. So therefore, if I give you 3 variables, you should be able to solve it if I give you 3 equations. So that's what we're going to work on today. It's called a system of equations, where I give you more equations and more variables. The skills still fit. We just need to solve now for x and y. We have to solve for an x and a y. Okay. So I'm going to do an example here, and we have done this in the past, because this is actually grade 11 curriculum, or grade 10 curriculum as well. I'm going to do something called substitution. Watch this, see whether this seems familiar. I'm going to take this little piece right here, the 3 minus 2y, and see how it's equal to x. What I'm going to do is I'm going to say, well, look, that could go in this place for x right here, and in this place for x right here, because really x is 3 minus 2y. Remember this, cool, okay. So it means I'm going to rewrite it like this. It was supposed to be 3x, but we know x is 3 minus 2y. Then there's supposed to be a plus y right here. Then there was supposed to be a 4x, but x is 3 minus 2y. Well, it's no longer multivariable. We're back to a single variable. The only variable I have left is y. And so now we go through the exact same processes that we just talked about. So, how do we solve this? Just talk through the steps. Okay, FOIL the crap out of everything that's here. So 9 minus 6y plus a y, and then that's a 12. That's a minus 8y minus 7. Then assess. Are we solving something linear or quadratic? Okay, because they solve different ways. If it's quadratic, you either have to factor it or use the quadratic formula. But if it's linear, it's a completely different set of rules. How do you solve this? Combine. Yeah, combine like terms. That's it. So get like all of your y's on one side. So for example here, see how there's two y's right here? Let's put them together. And then here there's some numbers. Let's put them together. And then I could say add 8y to this side. And I could add 8y to this side. I could subtract 9 from this side. I could subtract 9. What am I left with? 3y equals minus 4. Divide by 3. There, we got our answer. So linear stuff, don't forget, if you solve something linear, you're not using quadratic formulas and stuff like that. It doesn't fit. Right? Just literally get your y's on one side, your numbers on the other side, do the grade 8 algebra. So you see how really this is just one step up from what we've been doing, right? We've been learning about how to FOIL things. We've been learning how to solve equations, either linears or quadratics. The only step here is now we have to solve for x and y. I'm not done here. I solved for what y is, but I haven't figured out what x is. How do I solve for x? Well, that'll work. It's a lot of work, though. What do you say? Yeah, just throw it right into this equation here, right? Because we know that, I'll rewrite it here, x was supposed to be 3 minus 2y. That's what it was literally written right up here, right? X is 3 minus 2y. But we know what y is. Sorry, I had way too big of a gap here. We know that y is negative 4 over 3, so literally just plug negative 4 over 3 in for y, and now you know what x is. Out of curiosity, how many of you remember doing this last year? You guys don't remember this very much? I know this is probably just different focuses on teachers. So that was called substitution. So I'll make sure we'll do some more work with you guys as we need. Basically, we're just going to apply those skills now to more solving problems. Why don't I try another example in a second here. There's actually two different ways that you can do systems of equations. One was called substitution. Does anyone remember how elimination works? Stack them and cancel. Sometimes what I'd say, you want to stack two equations on top of each other and try to cancel one of the variables. So why don't we already did this one here using substitution. So let's skip this slide. Why don't we do this one here and let's try solving using elimination. Here's how this might look using elimination. I'm going to write them directly on top of each other. I'm going to write 3x plus y equals 4x minus 7. And then I'm going to write x equals 3 minus 2y. I'm going to write them right on top of each other. All right. Now, I need to pick a variable to eliminate. I need to have one of them where, like, when I add or subtract these equations from each other, the variable will, like, go away. And as of right now, I'm not actually in a good scenario for this to work. But I have a couple of ideas. Here's idea number one. See how there's a minus 2y over on this side right here? Could I take this minus 2y and just bring it over to this side right here and make it plus 2y? Is that a fair thing to do? That's not incorrect algebra. And then there's one more thing I'm going to do. I'm going to double the top equation. And I've already talked to a few of you about this. You can always upscale an equation if useful. Because I could make this 6x 2y 8x, and if I double this guy, it's minus 14. So I made two subtle little tweaks. The bottom equation, I pulled the y to the other side, and the top equation, I doubled. Anybody see what my end game is here? Why did I do those things? Is that louder? Okay. Yeah, the whole point of elimination is to get yourself in a scenario where there's 2y right here, and on the same side, right below it, I know they're not lined up, but right below it is another 2y right here. This is where elimination comes in. I'm now going to subtract these equations from each other and get rid of a variable. So you just have to take it side at a time. What is this 2y minus that 2y? Gone. Whole point. Okay. What about this 6x minus 1x? 5x. What about 8x over here? And then below it, are there any x's on the side of the equation? In a way, there are. There are none of them, if you really wanted to. I don't know why you'd write that. So what is 8x minus 0x? Well, still 8x, right? And then for numbers, we have minus 14, subtract 3, which would give us minus 17. We've gone now from having two equations and two variables to having a brand new equation with one variable. Is this linear or quadratic? So maybe subtract 8 from both sides. And then divide by minus 3. There, now I solved for what x was. You don't remember doing this before? Okay. I don't need you to remember how to do the substitution elimination like right off the bat here, because this is not on like your first assignment, I don't believe. Did I put one on there or not? Yeah, so this is not something that we're doing like in the next couple of days here, so don't freak out if you're like, oh, I don't remember seeing this, or it's been a while. So we have some time to work on this. But once you know the basic skills of taking two equations, blurring them together to get one equation, now you can solve something more complex. Now we're still not done though, right? If I tell you that x is this, we still have to solve for y. Yeah. All it means is just take this x right here and plug it, like, say, into this equation right here for that x, and you should be able to solve for y. So, concept-wise, how do you guys feel so far in terms of what we're trying to do here? Does this make sense? Because I feel like that's the lesson. Right? Now the question is, let's just find some examples and we'll build our way up. So let me try some more. Let's try this next one. So look at these two equations. Clearly we have two equations, two variables. We need to solve for x and y. We need to try to figure out whether or not we want to try doing substitution or elimination. Which one kind of fits better? And really it depends on the scenario. Sometimes elimination works better. Sometimes substitution works better. It's kind of your job to figure out what's the most efficient way of solving the question. Like I said with my analogy of trying to drive from Lethbridge to Fort Macleod. You can take the long way around, but sometimes there's a better way, right? That's part of what math is trying to teach you is pick an optimum way. I would suggest substitution right now is not bad because it's really easy to get one of the letters by itself. All I have to do is take this y right here and add it over to that side. One step, and I now have y all by itself. And that's a great way to start substitution. So now my new equation is 13x plus 2 equals y. Make sense? Where does this go? In the other, like literally like you substitute it, hence the name, in the other equation, right? So take this portion right here and shove it right where that y used to be. Just to save a step, can I FOIL this little piece out here while I'm at it? So make it 2x squared plus 8x. And then it was supposed to be equal to y. But we now know that y is 13x plus 2 plus 1. Don't forget like the plus 1 that was sitting back here, right? Like this bit right here is what y was. I've just changed it out. Okay, stop and assess the scenario now. What kind of equation do we have? Which is why we're doing this with the quadratics unit now, because now you have methods of solving quadratics. So, basic concepts. How do you solve a quadratic? It has to be equal to 0, and then you either factor, or if factoring looks like it's going to be a pain in the butt, and it's just not going to work, then just go to the quadratic formula. Okay, so let's play it out. Which side should I make equal to 0? I think we should bring everything this way. Seems reasonable, right? So let's make it 2x squared. And then I'm going to do some of this in my head here. 8 is going to subtract 13, so that's going to be minus 5x. And then 2 and 1 over here would have been 3. So bringing it the other way makes it minus 3. Are you okay with this bit? All 2 and 3 multiply to give 6, and there's a 5 in the middle. 5 and 6 is definitely a factorable combo. Let's write it out. We need to add to give minus 5. We need to multiply to give, what, minus 6? If you guys haven't come across the 5-6 combo, you got to be really careful. It's either 1 and 6 or 2 and 3. You just got to watch your signs really carefully because both kind of work, but only one actually works. Yeah, that's going to be the one, right? -1 and +6, -1, +6. Okay, so I'm just, honestly, at this point here, what's new about this? Right. This is exactly what you guys had learned the last couple of days. You get what I'm saying here? Right? So that's why this is a logical extension. All you got to be able to do is just factor and solve. What's up? Oh, did I screw this up? I need +1 and -6. Thank you. Okay, minus the fact that I screwed up the positives and negatives. Could we solve this from here? Like, is from this point on, is it new? Okay, when you guys do this next sort of stuff in the unit, I almost want you to think of it as like, what's a good example? Like, remember I had the Jenga tower that I used as my analogy last year? You've already built this base, hopefully, right? And if you're still working on learning how to factor, that's okay, right? But if you have the factoring base, all we just did is added a new layer on top of, well, can we do 2 equations, right? Because from here on out, I mean, I'll just blitz through this, right? You're going to do 2x squared with a -6, a +1, a -3. Hopefully this isn't really that new, right? I'm not saying it's not hard necessarily, but it's not new. Hopefully you'd agree, right? Okay, so I've got it factored. What are my answers? If this right here is my factor, what's the x answer? Okay, well, 2x plus 1 would have to be equal to 0. Subtract 1 from both sides. And then divide by 2. So this one gives me an answer of -1/2. Make sense? Good, funny looks. Am I okay here? Or did I go too fast? Okay. What about this one here? This is x minus 3, by the way. If x minus 3 is the root, then x is 3. Okay. Here's the change then. We have 2 answers for x. What's that mean for y? Because we still haven't solved for y. It just means we're going to have 2 answers for y. That's all. That's not a big stretch, right? All we got to do, I'm not going to do this step because I think you guys can, but all we have to do now is find an equation with y by itself, like say this one right here, and just plug in your values for x right here and get y. The difference is rather than there being 1x and 1y, there's now 2x's and 2y's. Right? I mean, how much more of a step is that? You get what I'm saying? So really from here on out, all I'm just really trying to do is just build up with new levels of practice. Do you guys feel like you get the main concept? Can I just leave it there and you guys would be able to solve for the x values? All right, let's try another example. Because really at this point here, that's what I want to do, just lots of examples. All right, this one right here. So first question, what would be a more effective way of solving, elimination or substitution? Is it easy to get one of your letters by itself? It's actually not that hard to get y by itself. In this equation right here, it's just 2 moves. I could bring the y to this side here, and I could bring the 10 back this way. It's actually not that bad to do elimination either, though. Because watch this, I'm going to stack them. I'm going to go x squared plus x minus 2y equals 0. I'm going to write that one out. And then I'm going to write the other one right below it, 5x minus y equals 10. Now, they don't eliminate just yet. But how could I modify the bottom one to make just a quick fix so that they will be the same? Yeah, let's double it, right? Don't forget, you can upscale things so long as you do it consistently. So I'm just going to write over top here. I'm going to double this 5 to a 10. I'm going to double this y to a 2y. I'm going to double this 10 to a 20. That's mathematically valid. Well, now I just need to subtract these equations. what is x squared minus, I'm not saying anything on purpose. What is x squared minus, well, it's still x squared, right? Because I don't have any other x squared to subtract from, right? What is x minus 10x minus 9x? Okay, here's the whole point of it. If this part doesn't work, we did it wrong. What is minus 2y minus 2y? Hence the name elimination. We eliminated it. So we don't even need to write it. And then what is 0 minus 20? Minus 20. I only have one equation left. My two equations have now been melded into one equation with only one variable. So back to our questions we have to ask ourselves now. What kind of equation am I solving? Linear or quadratic? Quadratic. How do you solve a quadratic? Make it equal to, and then factor if you can. And this one is really easy to factor. Add the 20 over to the side right here. What numbers, now it's a 0 here, right? What numbers add to give minus 9? Multiply to give 20. What numbers add to give minus 9? Multiply to give 20. Yeah, -4 and -5 in some order. So I can actually go right to this. X minus 4, x minus 5 equals 0. You guys know, you've heard of deja vu, right? The feeling that you've experienced something before. You should have that in math a lot, where it's like, we've been here before, right? From here on out, this is like my Jenga tower. We've been here. We've built these steps. This is nothing new to us, right? So all we got to do is just our last step. What does x equal? This guy right here means x equals, let's say again. You guys do know it, by the way, right? Like, I know you're not saying it out loud. You're okay? I don't need to freak out that you don't get it? Okay. 4 and 5. We're good? Okay, one more step, though. I have 2 answers for x. There's still probably 2 answers for y. So again, I just need to use a little bit of smarts and figure out which one of these equations should I plug my x's into to try to solve for y. And I think one of them is way easier than the other. Which one would you pick? The linear or the quadratic? I'd say the linear. Because really, all you got to do here is 5 times 4 minus y equals 10. Okay, well, 5 minus 4 is 20. Let's bring this y to the other side and make it positive y. Let's bring this 10 to the other side and subtract it. 20 minus 10 is 10. There we go. I have a y value of 10. You guys kind of do that somehow, however it is you do it yourself. And then all you got to do is the exact same thing with the 5. So 5 times 5 would have been 25. Bring the 10 the other way and minus the 10. I think the other one is 15. We now have 4 answers. 2 answers for y and 2 answers for x. And really all we're doing is we're just adding one layer on top of what we've already learned. Now, one of the things you guys would have learned yesterday with Mr. Bonnet, though, is that there are some quadratic equations that cannot be solved at all. Did you guys get to this part here? If I bring up the word the discriminant, you guys know what that means? So in the quadratic formula, under the square root, it's possible that the under the square root part is negative, and literally it means there is no possible combinations that ever work. That's also possible here, by the way. So if there's no possibilities for x, there's also no possibilities for y. I just want to point out that's also possible. You could have 1x, 1y, 2 x's, 2 y's, or 0 x's, which would mean 0 y's. So once you get those basics, you can solve a lot of cool stuff. So why don't I skip forward here to kind of wherever my end is, because it's all the same stuff. Why don't we just go right to the last one here and try a really challenging one and call it a day. All right, so first question, and hopefully, like, I'm saying these rhetorically, but hopefully these are kind of questions that you ask yourself as you're solving a question, right? First, what kind of question is it? Okay, it's a system of equations. How do you know it's a system of equations? There's 2 equations, right? Like, so hopefully that's the first thing you notice, right? Second question, how do you solve system of equations? Well, you can either use elimination or substitution. One of them is way better in this case. Both might work, but there's definitely one I would pick. I'd go substitution all day here. Yeah. Why? Well, I think the best reason why is that, look, I have a small little equation here. X is already by itself, right? I don't even have to do any work. I've just got to take y plus 4 and shove it into this x right here and that one right there. I have to do it in both spots. Okay, so rewrite it out. It now means that I have y plus 4 squared plus 2y squared minus 11y plus 4 minus 3y plus 31, and it's equal to 0. So, step 1, what kind of question am I solving? System of equations. Step 2, what's the smartest way for me to do this? Most of you seem to pick up substitution as the one, right? Step 3, do you actually know how to do substitution? I think I'm pretty good at that. Okay, now reassess the scenario. Now what do we have? Quadratic. I know it's not a very nice quadratic, but can you guys agree that there's going to be y squareds in this? Okay. So think a little further down the road. How do you eventually solve a quadratic? What do you need? Equal to 0. Hey, it's already equal to 0. Sweet. But this is not useful to us right now, right? What should I do? Why is this not like a useful format right here? Yeah, like what sort of skills did we work on previously that you want to work on here? Expanding and factoring. You know what I mean? Like we need to clean it up a bit, right? So, all right, how do you FOIL this first little bit? Well, actually, it's not y squared plus 16. You gotta be really careful here, because y plus 4 squared means you're writing it next to itself. Y times y is y squared. 4 times 4 is 16, but what did you miss? The inside numbers, right? Like, because there's a 4y right here, and there's 4 more y right there. So you actually missed 8y. So I'll just throw it on the end there. And then you need 2y squared right here. Now this bit I got to FOIL as well, so it gives me minus 11y and minus 44. Minus 3y plus 31 equals 0. Is it useful yet? Okay, so what math concept can you use here to help clean it up a bit? That's the one, yeah, combine like terms, right? I like doing this, by the way. I haven't shown you this. Use colors. I underline all of my y squareds. Okay, so I need 3y squared. Then in a new color, or sometimes I use shapes. This is just my trick, by the way. I would then say that I need the 8y. When I'm minus 11, I'm down to minus 3. And when I'm minus 3 more, I'm down to minus 6. And then the remaining ones I'll use black for. I've got 16. I'm going to subtract 44. Ugh, shoot, 16 minus 44. Okay, that looks like it's minus 28. But then I have to re-add 31, which is 3. All right. Everybody okay getting to here with the combining like terms? All right, last step. I need to now solve a quadratic. 2 main ways of solving. Option 1, factor. Option 2, quadratic formula. Just because I still have a little bit of time left here, why don't we do the quadratic formula just for an extra bit of practice? It may not be the most efficient way, but let's just try it just for practice sake. So here's the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. This is what our x will be. Let's plug in some numbers. What is b? Cool. But there's a negative in front of the b, so double negative it makes it actually positive 6. Then over here, we need to do negative 6 squared minus 4 times 3 for a and times by 3 for c all over 2 times, no, a is 3. A is 3. Now, I don't know what Randy showed you guys yesterday, but here's how I normally go about solving it. You guys can do your own thing. I usually put 2 things together. I usually put the bottom 2 numbers together, and then I find out what the whole discriminant mess happens to be, and that's my next step. That's just my personal preference. So I would write it as 6 plus or minus, and then 6 squared, I mean, minus 6 squared is, either way, plus or minus when you square it, it's 36. And then 4 times 3 times 3 is 24. So that's 36. That's 24. So when you subtract 36 and 24, you get 12. Did you guys get that, or did I screw this up? 4 times 3 is... You're right, sorry. Thank you. That's why I was wrong. Okay, so this is actually 0, isn't it? And then on the bottom, that's 6. Did he talk about what happens when the discriminant is 0? How many answers do you... Yeah, you just have one answer, actually. It's an anomaly. It doesn't happen very often, but like in the rare fluky scenario that this is equal to 0, then really what happens when you add or you subtract 0? You get nothing. You guys all okay with 6 over 6 being equal to 1? So how many answers for... Now, you got to go back up here and be really careful. You see how I wrote that x was equal to this in the quadratic formula, though? But what variables were I actually using right here? Y. Okay, so it wasn't actually x that's equal to 1. It's y that's equal to 1. And all I've got to do then is take y and plug 1 back up into here. X is 5. Okay, so quick summary. If you guys like my Jenga analogy, we didn't really actually add a lot of blocks to the tower today. Really, the only blocks we added were substitution and elimination, right? But if you can use the quadratic formula, which you learned yesterday, if you can factor, if you know your algebra skills, this is just like one step more than all of those. Does that make sense? Okay, if I lost you, by the way, please come ask me questions later, okay? So you guys can take off because that's basically it here. We'll talk to you guys another time. Let me know if that didn't make sense, though, okay?